Welcome once again to Exam Focus tutorial. Today we'll be discussing on variation. Variation. What is variation? Variation simply means the comparison between two or more variables. I come again, I said it has to do with the comparison between two or more variables. Quickly, I'm going to be looking at types of variation. We have the first one, we call it direct variation. We have the second one, we call it inverse variation. Inverse variation. And then we have the third one, we call it joint variation. Joint variation. And finally we have what we call partial variation. So we said that variation is the comparison between two or more variables. Now we said with respect to a constant, we said that we have four types: direct variation, inverse variation, joint variation, and partial variation. Quickly, we're going to be looking at direct variation. That is the first one we'll be looking at today, direct variation. Okay, friends, let's look at direct variation. What is direct variation? Direct variation simply means an increase or proportional decrease between two quantities. In a short term, we are trying to say that when there is an increase, a proportional increase between two or more quantity, it is said to be direct. Or when there is a proportional decrease, that is to say, if you are comparing two quantities, if the increase in one of the quantity you are comparing will lead to a proportional increase of the other quantity, then we can say that it is direct variation. Let's take practical example. Let's assume one person in the family can finish 2 cups of rice, and now they've increased to 2. It implies that if 2 cups of rice can go to one person, by the time they become 2, they might likely increase the cup of rice to 4. So the more the person, the more the cup of rice. So you look at the more the persons, the more the cup of rice. That will lead us to the increase. So let's look at this question. Given that x varies directly as y, if x is 10 and y equals 2, find constant to log connecting x and y, and then x when y equals 8. Let's take the question again. Given that x varies directly as y, if x equals 10 and y equals 2, find constant log connecting x and y, s when y equals 8. So let's get started. Solution. So let's interpret the equation. It said x varies directly as y. So this is how to state it. S varies directly as y. Then the next step is to replace these varies with equals k to introduce our constant. Remember, it's with respect to constant. Constant means that proportional value by which the increase or decrease is happening. So let's go. So s equals k y. Remember, we replace these varies with equals k. So let's input our value. We're told that s equals 10, k, and y equals 2. You divide both sides by 2 so that we'll get our constant. Therefore, k is equals to 2 into 10 will give us 5. So our constant is 5. Then let's answer question 2. Question 2 says we have answered question 1 constant, which is k. Now sometimes in some places they use c to represent constant. Here we are using k to represent constant. So our k is our 5. It means that the increase is happening by the constant value of 5. Now let's quickly look at the log connecting x and y. What is simply the log connecting x and y? The log connecting x and y means the relationship between x and what is that thing binding them together. What is that formula? What is that equation bringing them together? And if you look at the board, this is the equation bringing x and y together. S equals ky. So this is the equation bringing them together. So all you do is to write out this equation, then you will now substitute the value of k. Since we have gotten k to be 5, we say that simply the law connecting x and y is this our formula, which is S equals, since we've known the value of constant, the constant connecting them is 5, which is 5y. So what is actually connecting them is 5. So x equals to 5, y, that is the law. Now we have been able to write the law connecting x and y. And question part number 3, this time around they were told that x, we should look for x when y has increased to 8. Remember, y was formerly 2, now y has increased to 8. And so if we said that in direct variation, that increase in one quantity leads to the increase in the other quantity as well being compared with, as to say, if y has increased to 2, it means s must have increased from 10 to a different value. X was initially 10 and y was 2. Now y has increased to 8 from 2. That means x must have increased from 10 to a value. So how do we get this? Put down your formula again. S equals ky. What is x? S is not given. Y is 8. So we say S equals to, what is 5? We know that constant is 5 times y is 8. Therefore S is equals 40. So what we are trying to say now, that when y increased to 8, s has increased to 40. So in direct variation, an increase in one quantity leads to a proportional increase in another quantity, or reverse is the case, a decrease. So it's either both of them are going upward or both of them are coming downward. So they are always on the same direction. That's why it's called direct variation. It's either they are going forward together, the quantities you are comparing, or they are moving backward together. So that's it. So that's example 1. Look at it critically. If you have a question, you can also drop it in the comment section. We'll take another example. Let's take example 2. Okay, quickly want to take example 2, still on direct variation. So look at the question number 2. We said, given that A varies directly as the square of B, take note, given that A varies directly as the square of B, if A is 36 and y equals 3, find constant law connecting A and B when A equals 100. So let's quickly go. The first thing is to state our formula. We'll say that A, given that A varies, take note, given that A varies directly as the square of B, not just B, the square of B. B square means B raised to the power of 2. A varies directly as the square of B. Therefore, we say the next step is to replace this with equals k. Replace this with equals k. So we are replacing this with equals k. Remember, A equals k B square. So we were told that A is 36. K, B is what? 3 square, which is going to give us 9. So 36 equals to 9k. Then we divide both sides by 9. This will give us 36 over 9 equals k. 9 over 9. Look at it. 9k over 9. So that 9 will cancel, eliminate 9. 9 will eliminate 9. We have that k is equals 9 into 36 is 4. So our constant value there is 4. It means that the proportional increase on both variables, or both quantity A and B, is 4. So let's quickly look at the second part of the equation, the law connecting. I told you the law connecting simply means state out your formula and input the constant. So let's state our formula. A equals, what's now our constant we have gotten, which is 4, which is connecting both of them, B square. It's as simple as that. Let's look at question number 3 under this B when A is 100 B. So state our formula again, that A is equals KB square. This time around we're told that we are looking for B when A is 100. So A is 100 is equal to, take note, 100 equal to K. We know K already. K is 4, B square. So we divide both sides by 4. 4 will cancel 4. B square is equals to 4 into 100 is 25. Then B is going to give us the root. Remember I said anytime square is crossing equal sign, it forms square root. So this square will leave these two to form square root of 25, which, look at it, the square root of 25. Take note, square root of 25, square root of 25, please. This is 5, square root of 25, which will give us 5. So our final result will be 5. So please remember, look at the question carefully and be a master on this. Whether you are in JSS3 class, in SS1 class, you are in higher institution, 100 level mathematics, basic mathematics, this is on variation, this on direct variation. Please try to follow us on Facebook. If you're on Facebook, try to like, comment, share our videos on Facebook. If you are following us on YouTube, please try to subscribe. If you're enjoying our content, try to subscribe, and then come in the comment section, drop some topics you would like us to work on. We are here to make sure you are very good in mathematics. We want to eliminate anything that has to do with mathematics phobia and whatever. I want to eliminate that fear from people. And so please try to subscribe. If you're on YouTube, try to subscribe, comment, and then if you're on Facebook, try to follow, like, and share our videos so that people who need this can get across to it. So remember, this on direct variation. We're going to look at inverse variation in a short while. Okay, friends, we want to look at inverse variation. Now take note, we said that there is the second type of variation. We call it inverse variation. When you hear the word inverse, it's like saying almost opposite of what we have done in the direct variation. We said in inverse variation, what is inverse variation? The increase in one quantity will lead to a proportional or relative decrease to another quantity. That is to say, when a quantity is going up, another quantity will be going down. When the other quantity is going left, the other one will be going right. So in this case, we can use the law of demand as example. The law of demand: when the price of commodity becomes high, there are chances that the demand will reduce, because some persons might likely not be able to afford the same commodity. So if you did economics in the law of demand, you will discover that the higher the price of a commodity, the lesser the demand. The higher the price, the lesser the demand. So you see that when price is going up, demand is coming down. So that's an example of inverse variation. So let's take practical question. Look at example 1. Given that S varies inversely. Take note of this word, inversely. That is how you know your question, if it's under direct or inverse. If it was direct, they will say given that S varies directly. But here now we said inversely to mark the word inverse. So take note, given that S varies inversely as Y. If S equals 10 and Y equals 2, find the constant, the formula connecting X and Y, and then S when Y is equals to 4. So first of all, we are told that this time around S is 10 and Y is 2. So let's look for this. So let's set our formula. The first thing to do is to set your formula. So we'll say solution. So we set our formula. The first formula we're going to set quickly is to say that, let's interpret our equation. S varies inverse. Inverse of any value is 1 over that value. Take note, inverse of S is 1 over Y, rather. Inverse of Y is 1 over Y. Take note. For example, this marker, this how it is standing. If I turn it now, it becomes an inverse of it. Hope you take note of it. So remember, every natural number, every digit Y has an invisible 1. So when we turn it upside down, it becomes 1 over Y. So this inverse of Y is 1 over Y. So quickly, we have interpreted that S varies inversely as Y. Remember the next step I told you, you are going to replace this varies. Replace the varies. That is the next step. Replace varies with equals K. with equals k. So when we replace this, it's going to give us s is equals k 1 over y. So that at the end of the day, when you multiply, this will give us s is equal to k times y. Is it not k? We become k over y. So I've stated our formula. So let's now input. Let's input into the equation. So we're told that s is 10 and k, that's what we are looking for, constant, the first value, over y, which is what? 2. So we cross multiply. 2 times this, k is equals what? 20. 2 times 10 is 20. So I've answered question 1. Question 2 is simply the law connecting s and y. I told you that with the constant is one of the things connecting them. So we don't write our formula and input our constant. So which is s equals, instead of putting k now, we know k that is 20 over y. It's as simple as that. You have answered formula connecting x and y. That is as simple. I told you formula connecting x and y is the same thing as the law connecting x and y. It's the same thing as equation connecting x and y. It can also be stated as a relationship between x and y. Then let's answer question 3. Now we're told that s, we should look for s, find s when y is equals 4. So in our formula, our formula is equals to k over y. We're asked to look for s. What is 4? We know that our constant is 20 and our y is over 4. So which is going to give us equals to 4 into 20 is giving us 5. Hope it's clear. Look at it critically and get the understanding. Remember, I said if you have not subscribed yet, do try to subscribe. You want to be excellent in mathematics. You want to be having A1 in mathematics and all mathematics related subjects. Try to subscribe to our channel and follow us on Facebook. If you're on YouTube, try to subscribe. Thank you. Okay, still on inverse variation, we want to take example 2. Still on inverse variation. So we said given that L varies inversely as the square root, take note of this word square root. You must analyze each word, please. When you are trying to solve mathematical questions and you want to maintain accuracy, you must take note of each statement. You must analyze each word. Given that L varies inversely as the square root. So you first of all ask yourself, what is square root of m? If L equals 2 and m equals 64, find constant, equation connecting L and m, and L when m equals 36. So quickly, let's get started. Solution. Let's look at number 1. Solution to number 1. We're asked that, so let's interpret our equation. We say that L varies inversely. Remember, inverse of m is 1 over m, like we stated before. So we replace this varies with equals k, which will give us L equals k bracket 1 over m, which will now give us L equals k times 1 is k over m. So this is our formula. So let's input now. Let's substitute the values there. We are told that L is 2, and take note the square root, please. Let's state this clearly. Remember, we were told L varies inversely as the square root of m. Take note, square root of m, please. Take note, L varies inversely as the square root. Square root, look at it. Square root of, look at it, we have interpreted it as the square root of m. Square root of m, so that L will give us equals k. We already know k times 1 is k over what? Square root of what? M. Are we there? We say we are replaced with equals k, which is 1 over m. Okay, let's put it there for some reason. The person might be wondering. So at the end of the day, this will now give you L equals to k over what? Square root of m. Let's substitute now. Let's input our value. L is 2, K is what we are looking for now. We're looking for constant, which is K. What is M? M is 64, square root of 64. So at the end of the day, this will give us 2 is equal to K, square root of 64 is 8. Then we cross multiply. We'll cross multiply. When you cross multiply, you're going to have K. 1 times K is K. 2 times 8 equals 16. So our constant value is 16. Then let's answer question 2. I told us equation connecting L and M is the same thing as the law connecting L and M. It's also the same thing as formula connecting L and M. Remember, they are synonymous. Equation connecting, formula connecting, relationship between, law connecting, all of them are synonymous. They mean the same thing. So this will, let's look at it now. Law connecting them, I told you, is just to state your formula. This is your formula, and substitute the value of constant, which is L is equals, our constant is 16 all over square root of M. It's as simple as that. Equals to square root of M. Finally, let's answer the last question, the last but not the least. We're told to find L when M equals 36. So L is equals to, our K is 16. Let's state our formula again to remind ourselves. L equals to K over square root of what? M. So when we put this, L is not given. L is equals to, what is our constant? 16. Then square root of 36. At the end of the L is equals to 16. Square root of 36 is 6. Which will give us 6. 2 here is 3. 2 here is what? 8. So our answer is 8 over 3. Take note, the answer there is 8 over 3. Let's try to manage the space. Let's try to manage the space again. Let's start from there so I can manage the space. Question 3. We are saying that L equals K over square root of M. This time around, we are solving the third question. L is not given. K is 16. We have gotten K to be 16. Square root of 36. So L will give us 16. Square root of 36 is 6. So therefore, L is going to be 2 here is 8. 2 here is 3. So which is giving us 8 over 3. Our answer is 8 over 3. Thank you for joining us today on variation. Probably in our next teaching, we'll be looking at the partial variation and joint variation. Remember, once again, we started with stating that variation has to do with the relationship between two or more quantity with respect to constant value. Okay, now we say we have 4 types of variation: direct variation, inverse variation, joint variation, and partial variation. If you have not yet subscribed, remember to subscribe so that when we post new videos and new content like this, you can be notified. If you are not following us on Facebook, try to follow so that you can also be notified when we have future uploads like this. Thank you for joining the Exam Focus tutorial. Your success is our concern. Thank you very much. Okay, this is the practical question. Just look into it, work on it as a practice question, and drop your answer in the comment section. This is a question on, I wouldn't tell you the type of variation, so look at the question carefully and tell us the type of variation from which this question is drawn from the 4 variation mentioned, and then drop your answer in the comment section. Thank you. See you some other time. God bless you.